All right, so looking at our first question there, question 1, that's L, I should believe. The integral of, we're looking at the integral of x to the 4 minus 3x to the 2 plus 5 over x to the 4 dx. So we want to integrate that, but as it is, it'll be hard for us to just integrate it directly. Of course we can, but it will be hard and it will be time consuming. So the easiest way is to split. So as we know, by principles of mathematics, when you are adding whatever is on top and you have the common denominator, you can simply split them. And then when you split them, you have something like x to the 4 over x to the 4 minus 3x to the 2 over x to the 4 plus 5 over x to the 4 dx. So now x to the 4 over x to the 4 gives us 1, and that is the one that we have there. Then x to the 2 over x to the 4 gives us 3 over x to the 2. So we'll have that 3 over x to the 2. Then the other one will be plus 5 over x to the 4, then dx. So now, when we integrate those, we can integrate them individually. So you see that the one is a constant. So the integral of that constant will simply be x. And then we have 3 over x to the 2. When we integrate 3 over x to the 2, when you are integrating with x being the denominator, it's supposed to give you a negative. So it was supposed to be negative 3 over x. But then negative times the negative that we have there gives us positive, and it comes out as positive 3 over x plus 5 over x to the 4. When we integrate that, the integral of that will be a negative. So when we have that negative now, it will now be negative 5 over 3x to the 3 plus the constant of integration, which is c. So our answer is now x plus 3 over x minus 5 over 3x to the 3 plus c. But then one would ask, how do we prove that answer? So we can check that answer by differentiating our answer. We can check if it's correct by differentiating our answer. And then when we differentiate our answer, it should be able to give us what we had when we were integrating. So when we differentiate that, it should be able to give us what we had. So when we look at that, the differential of x is 1. The differential of 3 over x is negative 3 over x squared, plus the differential of 5 over 3x squared is that. Then when we add these, the common denominator will be x to the 4. So x to the 4, 1 into x to the 4 times 1 would be x to the 4. Then it will come out as it was initially, as we had in the first one. So it will come out like the question that we were solving. So hence we've proven that our answer is correct. Okay, I hope you guys are able to get me. Hope you are able to get me loud and clear. All right, so we proceed. We go to the next one. That is 1t. 1t is the integral of sec y, open brackets, tan y minus sec y dy. The integral of sec y, tan, open brackets, tan y minus sec y dy. So we are integrating this with respect to y. So what do? We expand. After we expand, we're going to realize that we'll come up with what is shown here. So we'll come up with something like this. So that is now sec y tan y minus sec squared y dy. So now we want to integrate this. But we know that when we are integrating, we can actually split the two because they are subtracting. So we can say the integral of sec y tan y alone minus the integral of sec squared y with respect to y. So when we integrate, remember, when we integrate sec y tan y from the identities, we're going to get sec y just. And when we integrate sec squared y, it will give us tan x. The reason is simple. The differential of sec y is sec y tan y, as we learned in differential calculus initially. Then, when you differentiate tan x, just as we learned in the previous one, we have sec squared y. Yes, there's a hand from Margaret Kudenga. You can go ahead. You can go ahead if you...
Yeah, sir. On the previous answer, and it's supposed to be tan x, tan y, not tan x.
Oh yeah, it's tan y. Sorry, that was a typo. It's tan y. Thank you for that reminder. It's supposed to be tan y. Right, thank you. So then let's proceed. Okay, so you can check this answer during your free time by differentiating that, and you realize that you go back to what we initially had. Okay, we move to question 2. So question 2, the A part. F prime of x is equal to 6x. So what they simply mean by saying f prime of x is equal to 6x, they are telling us that the differential of f of x is given by 6x. But then we realize that f of 0 is equal to 8, meaning before they differentiated the equation, f of 0 was giving 8 as the final answer. And then after you differentiate, you are remaining with 6x as your new equation. So for you to get the constant c, what do you need to do? For you to get the constant c, you will need to integrate your f prime x so that you go back to f of x. And then in that, after you integrate, you notice that after you integrate, you're going to have a constant c. But then what is that constant c? Then the equation that you have will be called f of x. So in that equation, the f of x equation, you are simply going to plug in 0 and find out what your c is going to be. So now we have this f prime of x to be equal to 6x. So f of x is equal to the integral of f prime of x dx, but the f prime of x is actually 6x. So the integral of 6x, you can add the dx there. I think we forgot to add the dx. You can add the dx. So the integral of 6x with respect to x is equal to 6x squared over 2 plus c plus the constant c. But then 6x squared over 2 is the same as just saying 3x squared. So 3x squared plus c is our f of x. So f of x is equal to 3x squared plus c, just as we have written it there. So now, what is our constant c? We've been given that f of 0 is equal to 8. So we are simply going to put 0 here. We put 0, meaning we'll replace 0 on wherever there is x. Then we equate it to 8 because we've been told that f of 0 is equal to 8. So whatever we're going to get, we equate it to 8 and solve for c. So since f of 0 is equal to 8, we'll have that now. We'll have that 3 replace 0 squared plus c is equal to 8. But 0 squared is just 0. 0 times any number, which is in this case 0 times 3, is just 0. So we just remain with the c. And so we say c is equal to 8. So we note that our c, our constant c, is 8. And showing how the initial equation was, the initial equation for f of x is supposed to be f of x is equal to 3x squared plus 8. Notably, when you differentiate this, you get to f prime of x is equal to 6x. And that is how we do that. That is how we find our C. So if you guys have a question, just raise your hand. If I can't see you, if I get busy and I don't see you, you're free to interrupt me and ask what your question is. Thank you. Okay. So the next one, I picked question 2E, which had f prime prime. So f prime prime, meaning this is like the 2y over the x2, the 2y over the x2. So meaning they differentiated twice. So this guy is telling us after they differentiated twice, they got 2. So now what was the constant C? So we're going to find two constants. The first one is for the first differential, and the second one is for the second one, the second integral, rather, the first integral and the second integral. So we've also been taught that when they differentiated once and they replaced a 2, the answer gave them a 5. Before they differentiated, when they put 2, the answer was 10. So what we're going to do, we're going to integrate f prime prime of x being equal to 2. We're going to integrate it so that it gives us f prime of x. And then f prime of x, we're going to plug in this 2 and then equate it to 5 so that f prime of 2 is equal to 5. So f prime of x is equal to the integral of f prime prime of x, which is equal to the integral of 2. And the integral of 2 is equal to 2x plus c. The integral of 2 is equal to 2x plus c. Notably, f prime of 2 is equal to 5. So what do we do? Where there is x in this f prime of x, we'll put a 2, then we equate the equation to 5, then see what we are going to get. So we are going to get that. Oh, someone is asking for the solutions. I think these solutions were shared, but I'm going to reshare it with your class reps. I'll reshare the notes. So f prime of x is equal to 2x plus c. So f prime of 2, which is now equal to 2 times, where there's x, you put 2 plus c. But then you realize that f prime of 2 is equal to 5. So 2 times 2 is 4 plus c. So we're going to have 4 plus c. We equate it to 5. So that's what we have down there. 5 is equal to 4 plus c. Then take the 4 the other side, it will be 5 minus 4 is equal to c. So c, your c now is equal to 1. So our first constant, that is, you can call it C1 so that you don't get disturbed. You can call it C1 is equal to 1. So our C1 is equal to 1. Or you can call it CA or C Roman numeral 1, whatsoever, just to differentiate it. Or C star or C naught. Yeah. So f prime of x is equal to 2x plus 1. So we now have f prime of x being equal to 2x plus 1. But then our main goal is to find f of x. So we're still going to integrate the 2x plus 1. So when we integrate the 2x plus 1, we'll come to this now. The integral of 2x plus 1 will be equal to 2x squared over 2 plus x plus another constant c. Because whenever you're integrating, you have to find a constant. So now our f of x will be equal to x squared plus x plus 1. Please, if your mic is on, kindly mute. Kindly mute your mic. We don't want to hear your private conversations. Thank you. F of x is equal to x squared plus c. X squared plus x plus c. But again, we were given on top earlier on. Let's just go back on top. Just go back on top. We were given that f of 2 is equal to 10. So since we found f of x, we can replace where there is x, we put a 2, and then equate it to 10. So we're now going to have that f of x f of 2 is equal to, where there's x, you put 2. It should be 2 squared plus 2 plus c, which will be now 4 plus 2, which is like 6. 6 plus c. Then that 6 plus c, since f of 2 is equal to 10, we can say 6 plus c is equal to 10. And then if 6 plus c is equal to 10, we can take 6 the other side, and then we can say 10 minus 6 is equal to c, and then c will be equal to 4. So our c is equal to 4. And then the equation will now come out as f of x is equal to x squared plus x plus 4. So that is the equation that we had initially, that we differentiated twice to get 2 as f prime prime of x is equal to 2. So that is how you go about it. Unless you guys have questions. If you have questions, please, you are free to interrupt me, ask your question, and I'll be able to attend to you. Or you can raise your hand and I'll be able to see that. So we come to this question 3. Are you guys getting me? I can just be talking to myself. You can show by maybe.
We are.
Oh, all right, wonderful. Thank you so much. Okay, so we now go to, okay, good. So we now go to the integral b dv is equal to negative gm, the integral of 1 over y squared dy. So basically, what they are trying to ask us is to show that this squared is equal to, if you guys have the solutions, I mean the tutorial sheet, you can check from your tutorial sheet, or maybe let me just open the tutorial sheet so that we can also refer to the tutorial sheet so that we can see the question. Are you able to see the tutorial sheet that I've opened?
Yes, sir. Yes, sir.
Right. So we are basically trying to show that this guy is equal to this. So we are trying to show that that guy, we are trying to show that this can be written as that. So we are trying to come up with what is down here. We're trying to come up with this. So now we want to prove that b squared is equal to b naught squared plus 2gm, open brackets, 1 over y minus 1 over r. So that is what we want to show. Okay, so we can go back to our solutions. So how do we go about it? The integral of b dv is actually b squared over 2. So the integral of b dv is b squared over 2, which is equal to the negative of gm, because gm is now treated as a constant. It's like a constant. Then we are integrating 1 over y squared dy. So the integral of 1 over y squared dy is negative 1 over y plus the constant c. But then since this guy has a negative and there's a negative outside, we can rightfully say negative times negative gives us positive. Yes, Alam Banda, what's your question? You can go ahead.
Oh yeah, so I've just observed when integrating v, you didn't put c, but when integrating y the other side, you have put c.
Okay.
You can just explain a bit.
Oh, all right.
Yeah.
Is it okay if I can explain that after showing the proof? Then I can show you how I moved about it.
Sure.
Okay, wonderful. So we have the negative, and the negative becomes positive, gm over y plus c. So now when y is equal to r, because in the question it was mentioned somewhere. When y is equal to r and b is equal to b naught, we are going to have that b naught squared over 2. When we replace where there is b here, we put b naught, we're going to have b naught squared over 2. And where there is y here, we replace with r, we're going to have gm over r plus c. So now that means our constant c is equal to, if we take gm over r at the other side, it becomes a negative. So it will be c is equal to negative gm over r plus b naught squared over 2. So from there, we can say where there was c in our initial equation, where there was c, because we had c somewhere, let's just go back. Yeah, here where there was c, we can rightly put our new equation for c. We can put negative gm over r plus b naught squared over 2. So now it is going to be like b squared over 2 is equal to gm y plus, instead of saying plus c, it will now be minus gm over r plus b naught squared over 2. So it will now come to this. And then since we have b squared over 2, we can rightly say, okay, this guy, we can multiply everything by 2 to get rid of the denominator 2. Then we're going to have b squared is equal to 2gm, because we've multiplied by a 2. So it becomes 2gm over y plus b naught squared minus 2gm over r. Then we can say b squared is equal to b naught squared plus, factor out the 2gm because it's common between these two, factor it out, plus 2gm. This becomes 1 over y. The other one becomes 1 over r. So it will be 1 over y minus 1 over r. So we've shown what we wanted to show. So we can say, hence we've proven that. We've proven that b squared is equal to b naught squared plus 2gm, open brackets, then we have those, hence shown. Then to answer the question that Mr. Alam asked. Okay, I'll try to write something. Hopefully you guys will be able to see it. So, Mr. Alam, if we integrated it, we were supposed to have b squared over 2 plus a constant c. But then to differentiate this constant c from the other constant c, which we are going to find on the other side, we can call it c1. And this can be equal to, can be equated to, then we can say that is now negative g m. I hope you're able to see what I'm writing. Negative gm, then open brackets, we have minus 1 over y, close brackets, then plus another c, which I'll name c2. Then, notably, we can take this c, let me just change some color. We can take this c, the other side. We can take it the other side. When it comes to the other side, Mr. Alam, are you able to see?
Yeah, I can.
Sure. So when you take it to the other side, it will now become to be something like C2 minus C1, isn't it? So now this C2 minus C1, it will still be a constant. A constant minus a constant, you still get a constant. But since you don't know what that constant is, you can still call it C. So it will now be C. So you've gotten a constant C. After subtracting C2, after subtracting C1 from C2, you've gotten another constant, which is C. And that's where I just got this constant. That's where I just said plus C. because I subtracted the two
All right,
constants
all right.
and then got the constant C. But that's a step I skipped and didn't show. So is it okay?
All right, thank you, sir. Yeah, it is.
Thank you so much. Okay. So any other question, guys? If you have a question, feel free to ask.
Hello, sir. Hello.
Yes, I can get you.
All right. Yes, kindly we just go through the thing which you've done. Just briefly to go through them.
Which things, sir?
Your solving, what you've done, just going through them.
What I've done, you mean
Just going through them for the second time at least.
the one I was showing where I got the C or what?
Not where you were showing the C, but just as you did at first, you just go through them briefly, because I've just joined the class. Not
So your network is very bad. I can't clearly get you. I don't know what your question is really about. I can't really get you. It's skipping.
Oh, I don't have. It's not a question. Hello, sir.
Yes, sir.
It's not a question.
Okay.
It being not a question, so I'm just go through the.
Just proceed.
To just.
Okay, you mean I go through question 3, showing how we derived it to the point of proving that b squared is equal to b naught squared plus the 2gm.
Yes.
Oh, all right, sir. So pay particular attention, sir. So we said the integral of this is this, b squared over 2 is equal to the negative of gm, but this gm is a constant, so the integral of 1 over y squared, it is 1 over y, negative 1 over y, plus the constant c. And that is the part I'm from explaining to say, when you subtract the constant that will be this side and the constant that will be this side, you still get the one constant, which is c, which is this c that we found. And then the negative and the negative will multiply. Then we say this is now positive gm over y plus c. When y is equal to r and b is equal to b, you can rightly say this is now b naught squared over 2, which is equal to gm over r plus c. Then we make c the constant, the subject. When we make c the subject, it is going to be c is equal to negative gm over r plus b naught squared over 2. Then you get this answer which you have found for c and place it where there was a c in the function that you initially had, which was gm over y plus c. So when you put it there, you're going to come up with something like this. b squared over 2 is equal to gm over y plus b naught squared over 2 minus gm over r. Then we multiply by 2 so that we get rid of the coefficient of, the denominator of b squared, so that we just remain with b squared as the subject. So it will now be b squared is equal to 2gm over y plus b naught squared minus 2gm over r. Then you can factor out the 2gm. You're going to get that b naught squared plus 2gm, open brackets, 1 over y minus 1 over r. So that is our final answer, hence shown.
Thank you. Thank you, sir.
You're welcome, sir. Okay, someone is asking for upload it on Moodle. Not really. Yes, Mr. Drugs. I don't know what those drugs are. You can ask, what's your question? And for that one who's asking for upload it on Moodle, I'll upload it on my YouTube channel. Be able to share the channel with you later on. Okay, Mr. Drugs.
Sir, go up a bit on this same question. Just slide up. Keep going. I want on that part where there's that negative. Yes, just there.
Reduce the volume from that music playing in
This
the background.
negative. Hello?
Reduce the volume from that music playing in your background, or just simply ask your friend to switch it off.
Okay, just a minute. Okay, go ahead, sir. Go Hello,
ahead.
sir.
Yes.
This negative, sir, how did you distribute it? Because on the previous step here, I can't seem to figure out how it also went inside, like inside the after integrating this 1 over y squared.
Sir, what is the integral of 1 over y squared? Sir, 1 over y squared can be written as y to the power -2, isn't it? So the integral of this guy,
Yes.
the integral of this guy is you add a 1 to the 2. So when you add 1, you're going to remain with -1, isn't it? Like that, isn't it? Then you're going to divide
Yes.
by -1, isn't it? So this is the same as, this y
Yes.
to the power -1 is the same as 1 over y. But then it's dividing by -1, so that's where the negative comes in. Clear?
Okay, thank you, sir.
Wonderful.
Clear.
All right, thank you. Okay, so I hope everyone is cleared. We can now proceed. Okay, so hence shown, we go to question 4. Question 4 reads xt is equal to t to the 3 minus 6t squared plus 9t minus 2, with that interval given there. So what we are basically looking at, let me just show you. This is the question. Consider a particle moving along the x-axis where xt is the position of the particle at time t. X prime t is its velocity and x prime prime t is its acceleration. If xt is equal to t to the 3 minus 6t squared plus 9t minus 2, with the interval 0 less than or equal to t less than or equal to 5, find the velocity and acceleration of the particle. Find the open t intervals on which the particle is moving to the right. And C, find the velocity of the particle when the acceleration is 0. So we want to work around that. So firstly, we'll find the velocity and acceleration of the particle. So how do we find them? We've been given here in the question that x prime is its velocity, x prime prime is its acceleration. So we're going to find x prime of t, meaning the differential of t, which is equal to 3t squared minus 12t plus 9. So that is its velocity. So we're not finding the actual figure, but we are finding an equation which represents the velocity. Then an equation which represents acceleration is 6t minus 12. So 6t minus 12. Okay, can you just mute your mic? Unless you have a question, mute your mic. So when the particle is moving to the right, its maximum is, this particle it has an increasing or whatsoever the acceleration is increasing. Yeah. So we firstly find what the critical points are. So we equate that guy to 0. So you'll find that when you do the factorization method, you find that you have that as your answer. You have t minus 3 and t minus 1. So t is equal to 3 and t is equal to 1. That is what you are going to have. So you have those points. Sorry for the interruption. So you're going to have those points. Then you're going to find the interval, because here it's asking us to find the t intervals on which the particle is moving, where this thing is increasing or this thing is decreasing. So the intervals will be like, this guy is increasing starting from 1 going down, and it's also increasing starting from 3 going up. But when you go in between 1 and 3, it will be decreasing. So the intervals are supposed to run from 0 to 1 and from 3 to 5, considering the initial intervals that we had. Guys, you're making noise. Can you mute yourselves? So from 0, your intervals are from 0 to 1 and from 3 to 5. So that is where that particle is increasing. Okay, then the C part, we want to find, it's telling us find the velocity of the particle when the acceleration is 0. So when it's not accelerating, what is its velocity? So we'll say, since acceleration is given by x prime prime of t, so we get x prime prime of t, which is equal to 6t minus 12, and equate it to 0. So we'll have 6t minus 12 is equal to 0, meaning our t will now be equal to 2. So the t that we have found is the time. At that time, t, we are told that the acceleration was 0. So now what will be the velocity at that time, t? So at that time t, we'll go to our formula for velocity. Okay, sorry guys, let me just mute these guys who are making noise. Henry Mbewe, you're making noise, sir. Okay, so velocity is given by x prime of t, which was equal to 3t squared minus 4t plus 9. 3t squared minus 4t plus 9. Christina, we don't want to know you. Mute yourself. So x prime of t is equal to 3t squared minus 4t plus 9. So now the time which was given is 2. The velocity, the acceleration was 0 at time 2. So we get that time 2 and plug it in the equation. So we'll find that our final answer will be -3. So -3, the velocity of the particle when the acceleration is 0. So it is, in short, it's not, it's on reducing, it's reducing its speed. So it's -3. Right. We proceed to question 5. Question 5, which I feel was very much easy. All right, so question 5, we go to the tutorial sheet, is saying, using properties of definite integrals, evaluate the integral using the following values. So we've been given that the integral from 2 to 4 of x to the 3 dx is equal to 60. The integral from 2 to 4 of x dx is equal to 6. And the integral from 2 to 4 dx is equal to 2. So now they are now asking us to find what the integrals of these guys are. So now how do we go about it? The first one, A, the integral from 4 to 2 of x dx. So this integral is the same as the integral of 2 to 4 x dx. The only difference is it's going in the positive, in the negative direction. It's going the other way around. It's like you've been given the distance from here to Kawe town. Then when coming back, how are you going to come back? You subtract that distance. So it will be the negative of the distance that you went to Kawe, that is coming back. So you can rightly say the integral from 4 to 2 x dx is equal to the negative of the integral from 2 to 4 x dx. But then the integral of 2 to 4 x dx is equal to 6. So the integral of 4 to 2 x dx is going to be equal to negative 6. Then the integral from 2 to 4 of half x to the 3 minus 3x plus 2 dx, this will be equal to, we can split these guys and say, okay, this is now the integral from 2 to 4 of half x to the 3 minus the integral from 2 to 4 of 3x plus the integral of 2 to 4 2 dx. So notably, x to the 3 has this constant. We can put the constant outside, and also this constant 3 on x, we can put it outside, and also the constant 2, we can put it outside and remain with dx. So now we're going to have that is going to be half the integral from 2 to 4 of x to the 3 minus 3, the integral from 2 to 4 of x plus 2, the integral from 2 to 4 dx. Then these were given. This is 60, this is 6, this is 2. So now we're going to say this is now half of 60 minus 3 times 6 plus 2 times 2, which will now give us 16. Yes, Mwinga Mala, you have a question?
Sir, kindly repeat on the first part.
Which first part, sir?
Hello?
Which first part, Mwinga? Mr.
Hello?
Male? Oh, okay, we can't get him. We proceed. We'll answer his question when he comes back. All right. We go to question 6. Question 6. Just check on question 6. It's saying evaluate the definite integral. Evaluate the definite integral. So when we're evaluating this definite integral, we want to evaluate k, 1 to 4, the integral of u minus 2 over the root of u du. So the integral will be equal to, we can simplify it, just like we did in the first one that we did. We can say, okay, since these guys are subtracting and they have the common denominator, we can say this is u over the root of u minus 2 over the root of u. So now we can say the integral from 1 to 4 of u, but then u over the root of u is as good as saying u times u to the power negative of half. Because u over root of u is like u over u to the half. So u times u to the negative of half minus 2u to the negative half. So when you integrate that, before you integrate, you find that these guys, u times u to the half, you add the powers, so it will be 1 minus half, which will just be u to the half minus 2u to the negative half. When you integrate, you're going to have something like this, and then the final answer will now come out as 2 over 3 u to the 3 over 2 minus 2 times 2 u to the half 4 over 1. I mean 1 to 4 as our points of integration. When you plug them in during your free time, find time to plug them in and be sure to find your final answer as negative 22 over 3. Negative 22 over 3. So that is how you go about it. Okay. Oh, I'm too fast. Sorry, I'll reduce the pace. Okay. So that is how you go about it. We can proceed. If there are no questions, we can move. All right, we go to question 6b. Question 6b has 0 to 4, absolute of x squared minus 4x plus 3x. So we note that the absolute of any number is equal to the negative of that number if that number is less than 0, or the positive if it is greater than or equal to 0. So finding the critical points of that guy, we will have those. So that means x is equal to 3, x is equal to 1. So I'm sure no one has problems with finding critical points. Critical points at this level, they are okay with you guys. So when you find critical points, the reason you're finding critical points is because you want to know where it is giving you negatives and where it is giving you positives. So notably from 0 to 1, it's positive, and from 1 to 3, it's negative. And then above 3, it's positive. That means from 3 to 4, it's positive. So we are going to say, we're going to split these guys. We're going to have the integral from 0 to 1. Then we are going to have the integral from 1 to 3. And then another integral from 3 to 4. So we are now going to add these integrals. But then the integral, since the interval from 1 to 3 is in the negative, so the integral from 1 to 3 will have the negative sign. Then we integrate with respect to x. So when we integrate, we're going to come up with something like that. X to the 3 over 3 minus 4x to the 2 over 2 plus 3x. Interval 0 to 1. Minus, because of this minus that is inside here, because of this minus, instead of positive, it will now become minus. So it will be minus x to the 3 over 3 and so on, with the interval from 1 to 3, and also the last one with the interval from 3 to 4. So when you add those, you will see that you come up with a constant solution. So during your free time, just plug in those values and see what you're going to get. So during your free time, you can plug in. It's easy, guys, from that point. It's easy. You can plug in and see what you got. Okay. There is no question again. We proceed. Okay, we now find the integral from 0 to pi over 4 of sec squared theta over tan squared theta plus 1 theta. So, notably, tan squared theta plus 1 is equal to sec squared theta. If you can't get that one, you need to revisit your identities, guys. You need to revisit them. So tan squared theta plus 1 is equal to sec squared theta. And then that means we'll have sec squared theta over sec squared theta, which is just simply equal to 1. Then we are integrating that. Sorry, where there's x, you should put theta, because we're integrating with respect to theta. So it will now be the integral of pi over 4, the integral from 0 to pi over 4 of 1 d theta, which is equal to theta. And then we have the interval from 0 to pi over 4. So we just say pi over 4 minus 0, which is simply equal to pi over 4 as our final answer. So visit your identities and find out that tan squared theta is plus 1 is equal to sec squared theta.
Is it not that?
Repeat again.
Sir,
Repeat again the question.
Can I just have one person to ask me?
Sir.
Yes.
Sir. Now, tan squared. Is it not tan squared theta? Is it not sec squared theta? Why? What of the one? Why did you take the one?
Tan squared theta plus 1 is equal to sec squared theta, not the other way around.
So is it the same like tan squared theta can be sec squared theta, just like that? Because the
No, it's not the
identity is like
same.
tan squared theta.
No, it's supposed to be tan squared theta plus 1 being equal to sec squared theta, sir.
All right, sir.
Good. The other one,
Sir,
what was the question?
we've put the x in block brackets. Can you repeat that again?
Oh, that's where I said I made a mistake because you know I like using x. It's supposed to be theta there. Then you plug in, the intervals are from 0 to pi over 4. So you put pi over 4 minus 0, just as you always do when you're integrating something. Is it clear?
All right. Yes, sir.
Is it Kambele? Kambele, go ahead.
Yes, sir. My question is, when you look at x here, you're saying x to x to the power pi over 4 minus x to the power 0. Now, why are you having pi over 4 instead of having theta to the power pi over 4 minus 0? Why are you just dropping this power as our variable, as our value? Yeah, that's my question.
Pi over 4
Hello?
is not, pi over 4 is not the square, sir. It is not the power, rather. But pi over 4 is one of the values that we are plugging in. It's like you are integrating from 0 to pi over 4. It's the interval. So you're integrating from 0 to pi over 4. It's not like pi over 4 is the power.
Oh, okay. Okay, noted, sir.
All right, thank you. Yes, I can see the other two hands. That is from Anthony Nkonde.
Yeah, so my question is on the tan squared plus 1. You're saying that it's equals to sec squared 1. Are we integrating tan squared plus 1 or what? Because when we say tan squared plus 1 is equals to sec squared 0. Because you can bear with me to say tan squared is same as sine squared 0 over cos squared 0, and then plus sec squared, it means to say it's 1 over cos squared. Now, when you are proving that identity, is it giving us 1 or what?
It is, sir. Go and check your identities properly, you guys. Tan squared theta plus 1 should be able to give you sec squared theta. Okay, the easiest way. You have your phones with you, isn't it? Can you just Google what tan squared theta plus 1 is equal to? Then the Google will actually automatically give you that tan squared theta plus 1 is equal to sec squared theta.
All right, so I'll check it.
Thank you. Weasel.
Yes, sir. Just to clear these guys who are asking about sec squared and the tan squared, there's a difference in identities between the integral of sec squared. When you integrate sec squared, that's when you're getting tan theta. But when on the identities of trigonometry, sec squared is equal to tan squared theta plus 1. I think they're confusing the trigonometric identities to the integral identity. Sec squared is equal to tan squared theta plus 1.
Exactly. Thank you so much for that clarification, sir. So guys, go and study the identities of the trigonometric identities. It's very, very important. Instead of complicating your life, they'll make your life easier actually when you're integrating such questions.
The integrated identities.
Okay, so let's move on. So at this point, before we start question 7, are there any questions? All right, so if there are no questions, from question 7 going down, since it's already an hour, you continue with
Question.
oh, there's a question. You can go ahead. Sorry for the interruption. I was discussing something here.
Yes,
Yes.
I'm not very clear on the previous question. Can you just go to the previous page? Yeah, I'm not too clear where I've put the pi in the block brackets because it's saying you're supposed to have pi over 4 there on top and down on 0, but you have just got a pi and you have placed in the block brackets there.
Oh, no, that's not pi, sir. Sorry, that's where I said I made a mistake because I usually work with x. So instead of pi, let me just show you what is supposed to be there. Instead of pi, where there's x here, remove the x and put theta. Put theta.
Okay.
Yes.
All right.
Thank you.
Sir, would you kindly share the solutions if possible?
Initially, we shared these solutions. You should have them. Ask your class reps. But anyway, I'll still share them. Yes, Shala.
Sure.
Build Shala.
Yes, can you kindly do the question which had the modulus just before this one, now the one we were dealing with the modulus?
Okay, I've recorded this video, sir. I'll post it. You'll be able to revisit the question. Is it okay?
Okay.
Thank you. Wizo.
So I wanted to ask about if you have the upper limit, the lower limit. Now the bigger number is down and the smaller number is up. How do you express it? Do you subtract the bigger number from the smaller one?
Yes. And that's why initially we were adding a negative. If you remember those questions on top, it shows that your final answer will come out as a negative.
Oh, so you multiply your answer by negative.
No,
by
not
negative number, by negative.
No, not really. We were showing, for example, the way it is from 0 to pi over 4. If we are finding from pi over 4 to 0, then it is equal to the negative of 0 to pi over 4. I don't know if you get it.
Oh, yeah.
So
All
showing
right, thank
that
you,
it's
sir.
very much possible to find from pi over 4 to 0, but it's just telling you that you'll find the opposite of finding from 0 to pi over 4.
So you just indicate your answer as a negative number.
If your answer gives you a negative, just leave it a negative. If it gives you a positive, leave it a positive. What I'm simply trying to say is it will show you that it will find the opposite of finding from 0 to pi over 4 instead of pi over 4 to 0.
All right, thank you.
Good. All right, so we go to question 7. Using the mean value theorem for integrals, find the values of C granted by the mean value theorem for integrals for the function over the given interval. F of x is equal to x to 3. The interval is 0 to 3, then f of x is equal to root of x. The interval is 4 to 9, and so forth. So we pick the first one. f of x is equal to x to the 3. The interval is 0 to 3. So a to b of f of x is equal to f of c times b minus a. I don't know if you guys can connect this from the theorem, the main value theorem. So initially we were having f of c to be equal to f of b minus f of a over b minus a, but we just made this integral the subject, meaning this multiplies this. Okay. So now f of c is equal to c to the 3, because where there's x, when we put c, it will be equal to c to the 3. So f of c is equal to c to the 3. So when we go down, the integral from 0 to 3. So now we picked this point, 0 to 3. And then we say the integral from 0 to 3 of x to the 3 will now be equal to c to the 3. Then b is 3. If you check on top, a is 0. So we have 3 minus 0, which is 3. So the integral of this guy is now x to the 4 over 4, with the intervals from 0 to 3, is equal to 3c to the 3. Then we want to find what the c is. So we plug in these values, and notably, they'll give us that 1 over 4 is equal to 3c to the 3. Then we're going to have that. So now we're going to have, when we multiply 4 times 3, it will be 12. So it will be 12c to the 3 is equal to 81. We divide 3 by 12. We have c to the 3 is equal to 27 over 4. Then the third root of that will be equal to 3 over the third root of 4. Okay, so others are telling me they are late. I'll still share the video, don't worry. 3 over the cube root of 4. So that is our C. That is what we have found. Then we have question 8a. Go to question 8. Go to question 8. Find the average value of the function over the given interval and all values of x in the interval for which the function equals its average value. So we want to find those values. Are you guys cool? Maybe you are tired, you need a break or something?
Just repeat on question 7.
Q18 to 7 to 9 hours.
You don't even know what you're saying. Okay, the formula is a to b, f of x is equal to f of c, b minus a. Then we note that f of c is equal to c to the power 3. So we just replace, then a to b, our a is 0, our b is 3. So a to b is the interval 0 to 3 rather. So now we are going to say the integral 0 to 3 of x to the 3 is equal to c to the 3, then 3 minus 0. Then we have the integral of x to the 3 is x to the 4 over 4. Then this would be 0 to 3, which is equal to 3c to the 3, because 3 minus 0 is 3. So now we're going to have that when we plug in those intervals, we are going to have that it will come to 81 over 4, which is equal to 3c to the 3. Cross multiply, you're going to have 12c to the 3 over 12, which is equal to 81. Divide by 12, going to have c to the 3 is equal to 27 over 4. Then you find the cube root to get rid of the power 3. So it will be c is equal to the cube root of 27 over the cube root of 4. And the cube root of 27 is 3. So c is equal to 3 over the cube root of 4. Is it clear? Grace Kanguya?
Sir, I don't know. How did you find the x4 as in on top? If you don't mind going on back on top. As in go. Keep going, sir. Yeah, there. Go down. Just down. There. X4 over 4, then x3 0. I really don't know how you found that. I've never understood on that part. So I'm asking if you can just explain on that part. Thank you.
Okay.
Thank you.
Formula for integral is when you integrate, it is x to the power n plus 1 over n plus 1, isn't it? So in this case, our n is 3. So 3 plus 1 is 4. So it will be x to the power 4. Then 3 plus 1 is 4 again. So it will be over 4. Is it clear how we got it?
Yes. Thank you.
All right. Okay. Thank you. So we can proceed. There's a hand from Bene.
Yes, sir. My question is on C. You say the integral of A and B, f of x is equal to f of C, then multiplied by B minus A, where C to the power 3 is the same as x, the function of A, f of x, just replace there. And then where there is B, put 3 and 0A. So now, what if you get a negative in the bracket here? Is it okay?
You can't get a negative, sir, because the interval always run from the smaller number to the bigger number. Hence, when you subtract the bigger number, the smaller number from the bigger number, you can't get a negative. Instead, you get a positive. You've seen the interval from 0 to 3. So it would be like 3 minus 0, not 0 minus 3.
Question, sir.
Okay?
The question, sir.
Yes, go ahead.
Yeah, I'm asking, is it always that is it that always f of fx is equals to ff of c?
Is it always that what?
F of fx. Yeah, because I have written it on top. F of fx is equals to ffc.
No, it's not ff.
When it comes to mean values.
It's not ff, sir. It is just f of x. It's just that when writing, the bracket came out as if it was f. Ben, stop making noise. Mute yourself. So is it clear, Anton? Okay. Drugs?
Yes, sir, it's clear.
Drugs?
So what if f of x is like a polynomial function? For example, x cubed plus 2x squared plus a constant. How do you do it? Plus a constant. How do you do it?
It's just the same, sir. You don't have to worry about that. You just get C and put where there is X. Then you get what will be your f of C. You get the point, huh?
Yes, sir.
Yes. So you just put C. So meaning you're not going to have one value. Instead, you're going to have different values. Just like a polynomial gives you. You're going to have different values of C.
Thank you, sir. I appreciate you.
You're welcome. All right, so guys, we move to question 8, and having utilized an hour, that means you continue with the other tutor, with Mr. Mkuka, with starting from question 8. So starting from question 8, going down, you continue with Mr. Mkuka.
So could also kindly drop your WhatsApp line on the text. On the text, what you cock chateau.
Right, you the Bob. Have a good night.
All right, noted. I will send my what. Okay, we'll send at the end. We'll send both our WhatsApp lines. We'll also send the YouTube channel where we're going to post this video.
Thank you, sir.
Okay.
When is the next tutorial?
Mute your mics. Mute your mics.
When is the next tutorial?
It continues right now. This is the next tutorial. So we're going to do question 8, yeah? Yeah, so now on question 8, the interest is that we've been taught to find the average value of the function over the given interval and all values of x in the interval for which the function equals its average value. So for the average value, just like the way you did with the mean value theorem, if you look at the formula for the mean value, when we go up here, you realize that we have the integral of a to b of f of x is equals to f of c times b minus a. Now for average value, it's like we're going to get rid of this b minus a. We're going to multiply it in front of this guy. It's like you're saying 1 over b minus a times b minus a here. So this and that one will cancel. Then also here we're going to have 1 over b minus a. That gives us the formula for average value that we are having here. Then when you have this part, the rest is now a piece of cake. You just plug in the necessary value. So you know that, for instance, here our f of x is equals to 9 minus x squared. You just put it here, 9 minus x squared, then yeah, so 9 minus x squared, then we know that our b is always the bigger number, right? So we come here in the interval, 3 is always our b, then our a is -3, right? So we come here, we plug in our b is 3 minus our a is -3. So this will give us 1 over 6, right? So now, when we're integrating from -3 to 3 here, you know that the integral of 9 is, since here 9 is just a constant, when integrating a constant, we just put a variable x there, right? So it will be 9x minus, then here again, we have x to the power 2. The integral of this guy, yes, sir, Weasel.
Sir, you're too fast.
Hey, I'm sorry, sir. I'm trying to catch up with Mr. Mkupa.
Vasa, we get you
All right, let me go back. I was hoping to finish fast, guys. All right, okay, let's proceed. Yeah? Okay, so I'll take it slow now. When we've been taught to find the average value, right? Our goal is that we just have to use the formula. Just remember that you can always create this one. What is important is you have to remember the formula for the mean value theorem. If you remember one, you can always create the other one. So if you remember this one, you know that you can always create the mean value theorem. It will be easy because for the mean value theorem, it's like you're going to, this b minus a, which is here, you're going to multiply b minus a and b minus a, you get back the mean value theorem. Then the opposite is also true for average value as well. So we've been given this formula here for average value is given by 1 over b minus a, the integral of a to b of f of x dx. Then from here, what you do is that most of the data is already given, right, in the question. So now that our function is given, our f of x is 9 minus x squared, which is here, right? Then we have the interval of a to b, which is we have a to b there, right? Negative 3 to 3, which is I've already shown here, right? Negative 3 to 3. Then b is 3, a is negative 3, right? Then what you do is just play around with the algebra there. You have 3 negative and negative, it's positive, right? So we're going to have 3 plus 3, which is 6, right? Then the integral of this guy, we can easily split guy. We can take the integral of this one here, the 9. The integral of 9 is just like we're just going to add x to the 9. We're going to have 9x minus the integral of x to the power 2 is like you're saying that 2 plus 1 over 2 plus 1 down here, which is giving us 3 x to the power 2, which is shown here. Is it clear or I'm still too fast?
There it was at least better.
All right, you proceed for me, eh? So now, when you have that part, now what you do is that since we have 3 and negative 3, we can start by plugging in the 3 which is on top, right? So we plug in the 3 where there's x here, we're going to have 9 times 3, right? Minus, there's a minus there, right? Then we put 3 again here to be 3 to the power 3 over 3, right? Then this 1 over 6, it will multiply everything. Huh? So when you have the first one, you plug in 3. This is the first one, the first part, right? Then you subtract it. Then you plug in negative 3 where there's x again. We're going to have this part here. So now you notice that when you have these guys here, when you simplify them, and you also simplify this guy, always multiply it by 1 over 6, which is outside this curly brackets. Huh? So what you do is that 9 times 3, we know that it's 27. Then we can always reduce, there are 3. There's 3 to the power 3 here, right? So it's the same as we can cancel 1 3, right? So we remain with 3 to the power 2. So 3 to the power 2, we know that it's 9, which is there, minus the minus, which is there. We know that 9 times negative 3, it's negative 27. Then we can reduce the 3 again here, going to have negative 3 to the power 2, which is just positive 9, right? So we're going to have negative 27 minus 9 there. So when you just subtract 27 minus 9, you have 18. Negative 27 minus 9, it's negative 36. Negative 36 times a negative, it's positive 36. Yes, Mr. Anthony, sir.
Just go one step behind. I just want to ask something. Scroll up. When we say 3 cubed over 3, when we cancel 3 and we cancel 3, we remain with 3 to the power. Now here on the minus 9 times negative 3 minus negative 3 cubed over 3. If it's the same, why are we finding that when we say 3 to the cubed is negative 27, which is negative times negative, it's positive. Now here when we cancel direct, it will give us a negative.
I've seen, sir.
Don't you think so?
Yeah, I've seen it. I think there was a mistake there. I miscalculated.
Yes, sir.
Is it okay? Thank you, sir, for the correction. So everyone make some correction on this one. Huh? Yeah, the good part is that we're interested in the concept. Huh? Yeah, for the algebra, it's you can easily do that. I can see you're doing a good job. Eh? Yeah, so it simply means that for the rest, you just finish it up because I think there's a mess there with the negative sign. Huh? Yeah. So we go to the next one.
Negative what?
Yeah, I think let's just go to the next one. Huh? I think this one, there was no messing up. Huh? Yeah. So we're looking at question 9. Question 9, we picked question 9b, this one. We're trying to find f prime of x. So you know that by fundamental rules of calculus, our goal is that when you have been taught to find f prime of this guy, always know that what you need down here should always be a constant. Then up here, that's where your variable is always based on. If, for instance, you have got this one here, question 9a, right? Want to find f prime of this guy, you have to play around with these variables here, x and x plus 2. Yeah, you play around with this. So you're going to have x, the integral of x to 0 plus the integral of 0 to x plus 2. Then this guy, all right, I'll just show you later on. Let's focus on this other one. Okay, we proceed. So like for instance, in this case, we're trying to find f prime of x, right? The integral of 0 to sine x over the root of t dt. So the first thing is that you always plug in where there's t, you plug in the upper integral in t, right? So we're going to have the root of f prime of x is equals to the root of sine x, right? Then multiply it with the derivative of the variable of this upper interval, right, which is sine x. The derivative of sine x is cos x. So that will be your final answer. Then you have solved for f prime of x is equals to the root of sine x times cos x. Is it clear, please?
Yeah, it's clear. So can we do the same even for part A?
Part A? All right, I was saying.
Yes.
Part A. Let me just check. Let me just
because
check
part
it.
A has an x down there and
All right, let me do it since we didn't cover it. Huh? Yeah, let me do A. So pay attention. Huh? So our A is given by the integral of x plus, okay, this guy here. Are you able to see from here, right? Yeah, so I'm trying to do this one here, right? So what we do is that we say this is equals to, right? So we're going to have the integral. The integral of x to okay. Okay, it's just that I'm experiencing some challenges in writing, but here on top you say the integral of x. Yeah, x. I hope you be following the concept. Don't mind my handwriting. Huh? So of x there, right? Plus
yeah, sure, sir.
Plus 2, right? Then here again, we're going to have x and x there. Are we okay with that part? Huh? Yeah, then inside here, we have
sure.
Yeah, imagine that this part I've already written it down. Huh? This part I've already written it down here, right? It's here, isn't it? It's my x. Then we say this guy is equals to, we're going to say the integral of x, right? Of x. Then here we're going to introduce 0. 0 there, right? Plus the integral again of 0 to x to x plus 2. Huh? Are we together there, right? Then since we know that for this part, when we put the function, this function, we just take this function the way it is. Huh? We put it there, isn't it? But for this guy here, what you need to do is that you change it a bit, right? You say is equals to, this guy is the same as negative, right? We introduce a negative by the principles of integration. Then we're going to say 0 down there, right? And then x, we put it on top, right?
And x on top.
Yeah, so of 0 to x, and also here we say plus this same thing which is here, isn't it? We can just bring it down here, right? Then from there, we're able to do the integration as the way we did it from the previous one, isn't it? Is it okay now?
Yeah.
Thank you.
Oh.
You have seen it, huh?
Nishapwa.
Yeah, Nish, you just do the remaining
Nishapwa.
part. Yeah, Nish, you are done. Yeah, the only part you have to work on is this part. Yeah, yeah, just play around with it. Yeah? Okay, we proceed. Yeah.
Sir,
Yes.
I'm lost on that part. Why did you introduce the
Sir,
zero?
just repeat a bit on that.
Oh my, I've already loved. Do I have to start drawing again?
Just finish solving, sir.
Yeah, so like for instance,
Just
here,
explain.
we're integrating from x to x plus 2, right? So you notice that the x down here, our goal is that we have to have only a constant down here, right? Here there should be a constant. Huh? So now, if here there should be a constant, what do we do now in order to get that constant? We know that the integration of x to 0 plus the integral of 0 to x plus 2 is equals to x, the integral of x all the way to x plus 2. These two are equal. Is it okay, please? Okay, let me try to draw it again. So I'm saying that the integral of this guy x and x there, right? Plus 2. This guy is the same as we're integrating. This guy is the same as we're integrating x. We introduce a 0 there, right? A constant. It's like we're dividing it into half, right? It's like we're having a middle guy. Just picture it that way. Plus the integral of 0 all the way to x plus 2 there, right? So you have that part. So you know that if this guy is equals to that guy, isn't it? We know that our goal is that we don't want a variable down here, isn't it? So now what do we do if we don't want a variable down there? It's the same as we're going to say this is equals to, we use another principle for integrals, right? Negative, the integral of now the 0 comes down. The moment you introduce a negative, the 0 comes down, 0. Then the x goes up, plus, then here are going to have the same thing, which is 0 x plus 1 there. Is it okay now? So you know that this guy here, our question here, this question here, this part here is equals to this part which is down here. Is it okay?
Yeah, it's okay, so continue.
All right, thank you. So for the remaining part, I believe we can use the the same concept, right? Because these ones are just the same. You'll be playing around. So even for this one, negative x and x, you have to play around with it to make sure that the lower one will always be a constant number.
So this one is confusing. So, try to play around with the remaining part.
Now, sir, I'm having a bit of challenge in terms of brain. I thought that in grade 7 and I've never improved since then. So I'm having a challenge in drawing, but if possible, I'll just try to write it in the solutions. Then I'll just send them. If you are not clear, then if you are in school, you can come through by the office. You are normally here.
Okay, sir.
Yeah, thank you.
Question.
Yes, sir.
This video is being recorded, right?
Yes.
Now, is it going to be available somewhere like maybe Moodle, YouTube, or somewhere?
YouTube, it will be available on YouTube.
All right, thank you.
You're welcome. Now
YouTube or somewhere.
we proceed now.
Thank you.
Yeah, we proceed. So just like I said earlier on, is that our goal is that when you have 0 down here, and up here you can have any variable, you can have sin x the way it is, right? That's our goal. So when you have these two parts here, what you need to do is that the first step is that you say f of this guy is f prime of x is equals to whatever function you have here, you're going to plug in where there's, for instance, where there's t here, you're going to put this guy which is on top. We're going to say the root of sin x times, we're going to take the derivative of sine, which is just cos, then that is our derivative f prime of x. Yes, Emmanuel.
Sir. For the case of the previous in front of the integral, so when replacing the sin x, we have to bring the negative back.
Come again.
Let's say we have a negative before the integral sign, that one.
Let's say we have a negative here.
You have to introduce a negative again.
Let's say we have a negative in front of this integral, like
negative.
We have a negative here.
Yes, sir.
Yeah, so when we have a negative here, then our final answer changes, right? So we are going to have a negative down there as well, which will multiply everything. Is it okay now?
Yes.
Okay. So now, when you have, let's say for instance, another one which looks like this one, we're trying to find the derivative by fundamental laws of calculus. When you have f of x is equals to this part here, what you need to do is that the first thing is that f prime of x is equals to, you get the function, right? Sine, open, where there's t here, we're going to put whatever they give you on top here. Hope it's clear on that one. What you need to ensure that you just have to have a constant down there. A constant must be down, then there should be a variable up there. So now we are going to have sine, then where there's t here, we're going to plug in x to the power 3, which is x to the power 3. Then there's a squared, we maintain it the way it is. Hope it's fine. Then we take the derivative of this upper guy here, which is giving us 3x squared. Then if you are done, you just play around with it. You're going to have 3 times 2 is x to the power sine x to the power 6. Then this will be 3x squared. Is it clear now? We do question 9.
Yes.
Right.
Not, sir.
Yes, sir. What's the problem?
Oh, no. Question 9, yes, I'm clear.
All right. So now we go
Question 9
to
is clear, yes.
question.
You can put it.
So I think I have a question.
Okay.
So what's the role of the integral sign?
What's the role of
that integral sign on the previous question?
This one?
Is question 9. Yes.
So what's the role of what?
The integral sign.
The integral sign. Oh yeah, the integral sign is necessary because when we're talking about, look at the fundamental theorem of calculus, what it states. When you read this book, Thomas Calculus, yeah, so by fundamental law of calculus, when we're trying to find f prime, this big F, right? There should be the integral there, isn't it? It's a to b. The integral is a to b of f of t dt. That's the standard theorem of calculus, right? It's f of x, this big F of x is equal to the integral of a to b of f of x dt, right? Such that when you're finding f prime of f prime of x, what you do is that by fundamental law of calculus, you plug in this upper one, which is b, right? You plug it in there.
Yes.
Then you find the derivative again of the same b, which is here again. Then you're done with the fundamental theorem of calculus.
All right. Thank you very much, sir.
Yeah. Welcome. What? Yes, Mr. Emmanuel.
All right. Thank you very much, sir.
In the we have integral of 2 to sine x. Do we ignore the 2 and just go and write, we replace the sine x into the function and do
You're talking
multiply by
about this one?
the derivative?
You're talking about this one?
If we had I didn't even see it, so I was just giving an example. So yeah, for that one, what do we just ignore the 2 and replace the x to the power 2?
Yeah, just ignore the 2 because our goal is that you just need the constant down here. You know that use the fundamental
All right,
theorem
sir,
of
thank you.
calculus. Okay.
So how about it?
Huh? Okay, we proceed. Yeah.
Just a minute. So you're saying any constant that is on the lower limit, you don't need to consider that one.
Yeah, we don't need to change it as long as it's a constant. When we differentiate, it still give us a 0 because the derivative of a constant is 0.
Oh yeah.
You have seen it, huh?
Yeah.
All right. So now we're going to this guy, question 10. The area A between the graph of the function, this function, right, and tx over the interval 1 to x is given by this guy here. Then the question is that find the horizontal asymptote of the graph of t. So know that the graph of t is this guy on top, right? Is that guy on top. Now, when you are finding the horizontal asymptote, we're simply going to take the limit as x approaches negative infinite and positive infinite, right? So now, let's skip question 10. Oh yeah, there it is. Huh? So now we're going to find the horizontal asymptote of this function, this graph of g, right? Which is given by 4 minus 4 over t squared. Now, when we take the limit as x approaches negative infinite and positive infinite from both angles, you discover that the final answer is always going to be 4, which is our horizontal asymptote. Then we have answered our question. And when you've been in the exam, when you have been taught to find the horizontal asymptote, please don't forget to show the negative, the limit as x approaches negative and positive infinity. Because most of you guys were losing marks. Yeah, so please don't do that in the exam. They present as well. So now the next one, part B, is telling us that integrate to find a as a function of x, right? So I'm going to integrate this guy here in order to find a as a function of x. What you do is that want to get rid this function t here, want to make this guy to be function of x rather than t. So what you do is that when you integrate now, given that ax is equal to this part, when you integrate 1 to x, 4 minus 4 over t squared dt, you're going to have, since this guy it's a constant, you're going to have 4t. Then here it's t squared, right? So it simply means that you have got negative 2 on top, right? So it will be negative 2 plus 1 is going to give us negative 1. Then negative 1 by negative 1, that's why we're having positive there, right? Positive 4 over t. And then here we put back our interval of 1 to x, isn't it? Then you plug in now in this function here, you're going to have 4x, where there's t, you put x, plus, where there's t again, you put x, minus, you put 1 here where there's t, plus, you put 1 there. Then your new function of a, which is represented as x, is going to give us this new guy here. When you have this new guy, then you have represented a, you have integrated a as a function of x. Then the next question is that, does the graph of a have the horizontal asymptote, right? So when you look at this graph of a, when you take the limit, you realize that this guy will be going to negative infinite, right? When you take the limit as x approaches negative infinite, it's going to negative infinite. Then we take the limit as x approaches positive infinite, it's also going to positive infinite, which shows that this function here doesn't have the horizontal asymptote because these two guys are not giving us the unique function or a unique variable or value. Hope it's clear on that one.
It's giving negative infinity.
Listen, when you're taking, are we together there? When you're taking the limit as x approaches negative. Listen, when you're taking the limit as x approaches negative infinity, you realize that the biggest value here, this guy is always going to go to 0, right? This guy, this part is going to go to 0, isn't it? But the limit of this part here, it's going to give us 4 times the negative, very big number. It's going to give us a very negative number, right? Have you seen it? When we plug in negative infinity, we're going to have negative infinity as our final answer, because this is the largest number we have in this function of ours, right? This function of ours, because we normally don't pay attention to a constant. We just concentrate much on this variable that we have in here, which is 4x, which is the biggest one, because this guy is going to go to 0. You have seen it, huh?
Okay.
Yeah. So when you plug in there, you're going to have negative infinite as our answer for this one. And then you do the same again. Now you are going to use positive infinite. Then you realize that when you plug in positive infinite, you're still going to get positive infinite, isn't it? Which shows that this graph has no horizontal asymptote. It's clear now, huh?
Yes, I'm clear, but
oh no.
That question is that how did you find that 4? Because that 4 I was trying to figure it out, but still negative, positive, and then it's giving 4. How?
Which one?
The horizontal asymptote.
This one here. This one here.
On top.
This 4 which is here.
Go on top.
This is the where we started from.
Scroll up.
This is where question 10 is starting from. The 4,
the same one here on top 4.
This 4.
How did it come out?
When we take the limit
Yes,
as x approaches negative infinite of 4, we are going to have what? Hello? Hello, sir. The limit of the constant is still the constant, isn't it?
Yes, it's a constant.
Yeah, so, but you notice that this guy is going to go to what? This is going to be 0. So what you remain is you're just going to remain with this 4 here, which is here. Is it okay?
Yes, sir, it's okay.
All right, thank you. So now we go to question 11, right?
Sir. Yes, sir.
Yes.
Yeah, I think I also have a question on that one. Can you just try to explain a bit how? Because if you say that 4 is a constant, then the limit of that 4 is given 0 as the x approaches negative infinity. Then what about that 4 on top there?
Let's do this, huh?
Yes.
You're able to see, right? So the limit as x approaches, we can just use 1, let's say positive infinite, right? Because regardless here, we've got x squared there, right? So let's use positive infinite of 4 minus the limit as x approaches infinite, right? Of 4 over t squared. You are seeing it, huh? What's the limit as x approaches infinity of 4?
That's and I understand now.
You have seen it, huh?
Yes, I've seen it.
Wonderful.
And go ahead. Okay. All right.
Okay. We go to question 11. So now, question 11 is telling us to show that the function, this function here, right, is a constant for x greater than 0. We're trying to show that this guy here is a constant for the value of x greater than 0. So what you need to do first is you have to integrate this guy here and that guy, and then you have to now show that when you pick a value which is greater than 0, this function is a constant. That's what they're trying to tell us there. So now what you do is that when you play around with 1 over t squared plus 1, most we didn't show the step, but there's a standard when you have 1 over t squared plus 1, that is tan inverse of t, then this would get this interval of 0 to 1 over x, 0 to 1 over x plus this guy as well is the tan inverse of t, 0 to x, right? 0 to x. Then when you have this part, we have integrated this now. What you need to do is that plug in what you have, 1 over x, you plug it in there, right? Then you know that tan inverse of 0, it's still 0, so there's no need to show that part. Then x, you plug it in, they are going to have tan inverse of x. Then you know that tan minus, it should be minus tan inverse of 0, but you know that tan inverse of 0 is 0. So even if you don't show it, it doesn't matter, isn't it? So we have tan inverse of 1 over x plus tan inverse of x. So now, want to pick a constant that will be easier for us to find. So looking at 1 over x and x, we could think of picking 1, isn't it? Let x be 1, because 1, we know that, already know that using those trig things that we learned last time, we know that the tan inverse of 1, it's 45, isn't it? So it's better if we pick the value that we know that it's easy to give us, because we don't use calculators in there. So we can pick 1, being we know that 1 is greater than 0, isn't it? So you know that tan inverse of 1 plus tan inverse of 1, we're going to have 45 plus 45, which is giving us what? 90. Then that's the constant we're interested in finding. Is it clear on this one?
Yes.
Throw a little bit up, sir. A little bit up. Yes, yes, sir. How is tan inverse of 1 over 2 becoming also 45? Is it all of my identities?
No, no. This is tan inverse of 1 over x. Is it okay? This is x here, 1 over x.
Oh, I thought it's 2. Okay,
No,
sir.
it's
It's
x,
okay
sir.
now.
All right, sir. So we go to question. It's 12 now. Question 12. I think this will be our last one. So question 12, we've been asked to say, find the function f of x and all values of c such that c to x, this integral of f of t is equals to this part here. So now, when you look at this f of t here, by fundamental theorem of calculus, you know that when we take the derivative of the integral of a to b of f of t, we're going to say this guy is equals to f of x, right? So in order for us to find this f of x, we're going to differentiate this guy here and also differentiate this part, which will give us what our f of x. So like shown here, like, is it shown here that when we take the derivative of this integral here, this part c to x of f of t dt, we're going to have f of x, right? Which is equals to, we take the derivative as well from the right hand side, we're going to have the derivative of x squared plus x minus 2 is equals to 2x plus 1. So we know that f of x is equals to 2x plus 1. When you have done the first part, you'll find your f of x. Now, another question is that if you find f of x, right, find find the values of c such that this thing holds true. So what you do to find in the value of c, to find those values of c, you now plug in now. You know that the f of t, you know that you will find f of x equals to 2x plus 1, right? Then in this normal integrand of ours, this guy will have f of t, right? So we simply plug in where there's x, we put a t. We're going to have this new function here, which is f of t is equals to 2t plus 1. We plug it there now in our integrand. Huh? So now, when you have this part is equals to the same thing which you have here, we know that f of t is equals to this guy here. You also equate it to that. So now when you equate these two, what you do is that you first integrate the left-hand side, right? So when you integrate 2t, you're going to have 2t squared over 2 plus the integral of 1 is just t. Then you say c all the way to x, right? Then you plug in x in this function. You plug in x, you're going to have x squared plus x. Then you also minus, you plug in c, you're going to have c squared minus c is equals to the same thing on the right, right? Then you play around with these guys, you're going to multiply, you're going to say x squared plus x. Then here, when this guy, x squared, comes the other side, it's going to be x squared minus x squared, which will just be 0. then x minus x will cancel, right? So when the 2 jumps the equal sign, you're going to have positive 2 there is equals to 0. Then you can multiply a negative throughout so that you have c squared plus c minus 2 is equals to 0. So from there, you can just solve that guy quadratically, or you can easily find the sum and product rule. So you should have your final answer should give you c is equals to -2 and c is equals to 1. That's how you solve question 12. Then if you are done, you have found your f of x, and you have also found the values of c such that this thing holds true. Is it clear, please? Yeah, wonderful. I think we can end here for today. We'll proceed. We'll proceed next week, but we'll send the solution in advance so that when explaining, you can easily follow.
Our inbox users they can also share to my group.
All right, sir. We'll see you next time.
Should be
You can also
yeah, you're going to
share to us.
Oh, before you go, guys, just check in your charts, put in our contacts.
the next area.
That's the contact for Mr. Mukuka, the one who was just from you. Then that's my contact, and then the YouTube channel is that. Just search for Skongo Chilala, you'll be able to access the videos. We'll let you know as soon as we upload the videos. Just give us about 30 minutes, we'll be able to upload. If you can't find it, I'll still send, you can inbox me or you can inbox Mr. Mukuka to just give you the direct link to the video. Okay, thank you. Enjoy your evening.